Okay, today we're going to be talking about section 4.8, which is imaginary number system. And basically what it is it's talking about when you can take the square root of a number. So we already talked about roots a little bit last section and how we're trying to find perfect squares. The same rules applying, but this time we're going to be talking about what happens when you have a negative underneath the square root symbol. So the square root of 4, we learned last lesson that was going to be 2 squared, which power and root canceled out to give you 2. However, that meant that there were 2 2's inside there. Now there is not a number multiplied by itself that gives you positive 4. The only way you can get a negative 4 is negative 2 times positive 2. Those are not the same number. So that means you can't do it. So what we did is we developed a new number system, which is the complex number system or the imaginary number system. And that exists only to take the square root of a negative number. It only exists to take the square root of a negative number. So the complex number is the form of a plus or minus bi, where the a is the real number and the imaginary number is the bi. Okay? The biggest thing that I need your guys' brains to remember is that I squared is equal to negative 1. Why? Well, yesterday we learned all of these perfect squares. 1 squared equals 1, 2 squared equals 4, so forth and so forth. And remember I said everybody probably goes up to pretty well to 10. You need to try to remember these ones as well to help it make it a little bit easier for you to do your calculations. Now, what I want you guys to do is every time you see this, I want you to immediately say negative 1 times the number. Negative 1 now becomes I squared. 16 is already a perfect square, so we leave it alone. So the square root of I squared comes out as an I, and the square root of 16 comes out as a 4, so my answer is simply 4I. Okay? We're going to do that again. So again, I see a negative, so that's going to be negative 1 times 9. 9 is already a perfect square. I squared is negative 1. 9 stays. The square root of I squared comes out as an I. The square root of 9 comes out as a 3 to give me 3I as my answer. And this is exactly the way I want you to do tonight's homework. Exactly the way I'm doing it here is exactly the way I want you to do it. Okay? Next, same thing. This is a little bit more though, so this is going to be negative 1 times 18. Then negative 1 is I squared. Then we're going to come over to our factor finder. And on our factor finder, this is our calculator soup. Okay? So if we're doing our calculator soup, we're going to go ahead and put the number 18 in here. And we're going to find the perfect square factor, which is 9 times 2. Okay? So if we're going to be doing 9 times 2, then I'm going to go ahead and take the square root of just the numbers that are perfect squares. So the I comes out, and then the 9 comes out as a 3 to give you 3I, and the square root of 2 is what is left. Okay? Same thing. This is negative 1 times 48. So this is going to be I squared times. Come over to your lovely little factor finder, put 48 inside there, and you are going to use 3 times 16. So this is going to be 16 times 3. The I squared turns into an I, the 16 turns into a 4, to give you 4I square roots of 3. Okay? Let's do it again. Negative 1 times 45. Negative 1 is I squared. Come over to your factor finder, make this a 45, and the perfect squares are going to be 5 times 9. So the I squared comes out as an I, the 9 comes out as a 3. So I have 3I square roots of 5, and that is done. Over here, negative becomes a negative 1. I squared is going to turn into the negative 1. Come over to your calculator soup, clear that out, put into 72, hit enter, and you're going to have 2 times 36. So this is going to be 36 times 2. I squared comes out as an I, 36 comes out as a 6, and you're left with 6I square roots of 2. Okay? So basically I've shown you how to simplify all of the nice ones with imaginary numbers underneath of them, with a negative underneath the radical. how do I graph these? Well, if I want to graph, let's say 3 minus 7i. Here's what your brain needs to understand. The x-axis is the real axis, and the imaginary axis is your y-axis. So I am going to go over 3 units on my real axis and down 7 units, 2, 4, 6, 7. So this is the point 3 minus 7i. If I wanted to graph negative 2 plus 4i, I go over 2 units on my real to the left, and then up 4 units on my imaginary. So that's negative 2 plus 4i. If I wanted to graph just negative 3i, I would only go down 3 units on my imaginary axis. Okay? Now, how do I solve equations? All right, so let's go ahead, and I'm going to solve for x by adding 10. So I have 4x squared is equal to negative 36. Divide each term by 4, and I'm going to get x squared is equal to negative 9. Now I need to take the square root of both sides. So that's going to be x is equal to plus or minus. This is going to be negative 1 times 9. The negative 1 is going to turn into I squared times 9, which pops out as an I, and this pops out as a 3, so x is equal to plus or minus 3i. Okay? We're going to do that again. So if we do that again, we're going to go ahead and add 5. 3x squared is equal to 30, which is a negative. Divide by 3. X squared is equal to negative 10. The opposite of a power is a root. So x is equal to, put the plus or minus in front. This is negative 1 times 10. What is negative 1 equal to? I squared. So that means the I squared comes out as I. And you have x is equal to plus or minus I square roots of 10. 2 more examples like this. Subtract 35. 2x squared is equal to negative 48. Divide by 2. X squared is equal to negative 24. Take the square roots. X is equal to plus or minus negative 1 times 24. So that's going to be plus or minus I squared times 4 times 6. I squared comes out as I. 4 comes out as a 2. So it's plus or minus 2i square roots of 6. Last example. Divide by 6. X squared is equal to 9. Take the square root. X is equal to just plus or minus 3 because it's not negative. Tonight's homework is going to be Board 8, Worksheet 1. Simplifying imaginary numbers and square root equations.